Welcome to listen a presentation about RESERVIST Digital Platform. My name is Timo Salmi and I'm from VTT, Technical Research Center of Finland. RESERVIST Digital Platform is a part of a Reservist project that has received funding from the European Union's Horizon 2020 Research and Innovation Programme. This presentation is deliverable 5.2 of the Reservist project and it is named Intercompany Communication is operational via Reservist Digital Platform RDP. The outline of this presentation is firstly the introduction, including about Reservist project, RDP core functions, about basic technical solutions and selected technologies, then the results, platform access management, marketplaces, situation awareness services, and trusted data transfer services that are made via IDS technology. And finally, conclusions and acknowledgements. And then let's start with the introduction. The long name for Reservist project is Repurposing Manufacturing Lines for Providing Medical and Other Products and Services in Case of Spiking Demand Times. The Reservist concept has been to create Reservist-cells that in times of crisis can be activated within 96 hours to switch to manufacturing of medical products and services that are spiking in demand. To realize this concept, work will be done on three levels: individually, network level, connected manufacturing or digital manufacturing level, and technical level. The latter referring to tweaking manufacturing lines, developing required materials, and establishing links with testing and certification. The Reservist Digital Platform RDP has been developed to support the network operations and its marketing. If we think the role of Reservist network in the market, typically Reservist-cells are not active in ordinary times. They are activated in times of crisis, when the ordinary capacity is not able to fulfill the needs or there is disturbances in the ordinary supply network. Typically, the Reservist partner's core business is in another business areas. The companies also have own production control and order handling systems. So it was no idea to create any parallel systems for operational processes. The focus was set on preparedness and the ramp-up process, which are critical in the repurposing. The core functionalities for the RDP was defined to be marketplaces for end products, materials and services. The other core area is situation awareness services. RDP offers also possibilities for trusted data transfer services between partners or between a supplier and a customer. For operational functions, companies use mainly their current information systems. The marketplace for end products is for end users, the marketplace for materials for production companies, mostly for reservist suppliers. The marketplace for services are for production companies, but also for governmental organizations or product distributors. The situation awareness services are for reservist partners and special customers. The aim is to support preparedness that the companies would be ready for ramp-up when it is time to be activated. The situation awareness means emergency reports for the reservist suppliers. It contains also knowledge database that includes general information about emergencies and their features. Reservist project has also created a system dynamic model to simulate the needs of consumables in crisis. So the RDP creates value for end product producers, material suppliers, service providers, and for customers like hospitals and governmental organizations. Then we go to the basic technical solutions. RDP is a web-based software tool where the data is maintained by a simple real-time context management database. Reservist data model is based on Five-style entity model. It uses linked data approach. That means that all references between entities are uniform resource identifiers. User interface is kept simple and flexible by supporting automatic generation of UI forms and reports. RDP user interface functionalities manipulate the state of entities in the database. RDP has designed so that a trusted communication can be provided by international dataspaces reference architecture. And then we go to the selected technical solutions. JavaScript object notation schema is used for data model implementation and JSON LD for mapping to the IDS data model. React.js JavaScript library is used for user interface development. React.json form library generates automatic user interface forms from data model JSON schema. Authorization and user management is made with Keycloak service. VTT IDS Sandbox and open source IDS dataspace connector are used for trusted communication. And now we go to the results of the embedding. User authentication is based on Keycloak, which is an open source identity and access management tool for web applications. By using Keycloak, it is possible to assign different roles for the users. That enables access to different functions according to the roles. Users are added by the platform administrator. Users may enable and complete account using the forget password function in the RDP sign-in. Now we go to the Reservist Digital Platform. There is firstly the welcome page and some basic information about the Reservist Digital Platform. Here it is information about the Reservist project, and at the end of this page there is a link to the Reservist project web pages where it is more information about the project. Here it is more information how to join into Reservist network as a supplier. And here it is possible to fulfill a form and tell about your offering. There is firstly those contact information and information about your organization, and finally about the products or services you want to offer. And submitting here the form sends the application to the coordinator. After sign in, we come to the main menu where all platform services comes available. It is also expected that all users would register into the platform. Also, the Reservist marketplace for products open. It shows all Reservist product offering. A supplier can inform the availability of the product with the color. We can take type 2 medical face mask as an example. Here. The presentation has firstly a short free text description, then there is a product category, and what is the compliance with the standards. There is also an optional price information. It is also given a minimum order quantity and expected delivery time. In the bottom of the page, there is a button where the customer can open a form to tell about his or her needs. Here. The description of the needs. Here. And some additional information, and also the expected delivery time, quantity, and contact email. After fulfilling the fields and pressing the save button, it creates a notification to the supplier into the platform. It also opens email application and generate an email to the supplier. Product presentation by pressing the new button and then going to the edit mode and then fulfilling those fields. Product description, an image. It is possible to add as a link. Product category can be selected. And stock situation can also be selected. And it is also shown as a color in a list. Price is optional. Also minimum order quantity, delivery time, and then contact information. The product description is written automatically when fulfilling the fields, and if we save the description, it would come to the offering, but we cancel the editing. There are also similar marketplaces for materials and services. Marketplace for raw materials. It is mainly directly to the reservist end product manufacturers. It is also possible to make an announcement about the need of any material that the user is searching. The button Send inquiry on a material opens a form for that purpose, where the customer can make an announcement of his or her needs. The marketplace for services presents services related to repurposing of production to medical products. The target group is production companies and governmental organizations. One area of the services is related to quality assurance and certification of the products. There is quality assurance services related to official certification, but also so-called alternative test providers that can offer fast tests and help in the situation when the official certified test laboratories got jammed. Behind the button, learn, design and manufacture with makers. It opens a link to FabLab community and its services. There is a link to viral design book or video of the resilient maker stories. The FabLab community includes currently about 1,000 labs around the world. Here it is also possible to fetch FabLabs according to the parameters. We can, for example, try to find FabLab that have had corona activities and they offer in 3D printing. And here fetch. And so it is searching. And then submit. So we can see the search results here. Those FabLab that has 3D printing and they have had corona activities. Other main area is situation awareness services. Firstly, there are emergency reports made by reservist coordinator who follows all the time what's happening around the world. The coordinator brings here processed information for partners about emergencies. As an example, we can take Sudan conflict from this spring. It includes short description, category, scale, presumable needs. The report may be updated when more information comes available. If the coordinator saw that the emergency has a potential to escalate needs that the suppliers should ensure their preparedness, the coordinator can generate a wake-up signal to the suppliers. In practice, the function generates emails to all reservist suppliers. Wake-up call is behind this button. Situation awareness includes knowledge database for partners and selected customers. It is firstly general information about different types of emergencies, their characteristic features and typical needs. As an example, we can take an earthquake. It includes definitions and information about typical medical needs and challenges related to material supply. There is also some different general information available in these pages. In the knowledge database, there is also specific information about the system dynamic model that was created to forecast needs and offering of consumables in the pandemic. The development of the IDS is led by International Data Spaces Association Its goal is a global standard for international data spaces and interfaces, as well as fostering the related technologies and business models that will drive the data economy of the future across industries. Idea is that the data providers can themselves determine the data usage rules. The central technical component for data exchange is the IDS connector. This technology can support trusted data sharing in RDP either between reservist partners or customers with their own certified IDS connectors. Because data is shared in IDS through connectors, each IDS dataspace partner needs an authorized access to at least one connector. The user can request access to data in other connectors through its own connector. Also, a connector application programming interface (API) can be accessed programmatically by legacy systems or user interface. IDS contract and its rules manage the access policy for shared resources. When a resource request is accepted, data is copied into user's own connector and a download link to it provided. And how IDS is implemented in our RDP. Connectors are offered for all partners in a cloud service. Partners can also install connectors in their own IT systems and add its description in the RDP. RDP user interface provides a simplified access for the connector defined in RDP. RDP has also a common connector that provides restricted access to the reservist dataspace and shared resources that are writable by multiple partners. All partners can write into the resources on their own connectors. They have also access to read catalogs of other reservist connectors. They can request access to read from other connectors. Reservist connector information is saved also in RDP database, so the data is available without access to IDS brokers. Reservist data model schema is supported by JSON schema templates. They are used for generation of user interface forms that are used when data is written into resource data in JSON format. When going to the trusted data transfer service, available connectors are shown in RDP. You can connect to the desired connector, and then after selecting a catalog, the resources can be seen and written. The IDS technology was demonstrated in distributed quality assurance certification concept. It simulates a crisis situation when face mask certification services are congested. Delivery times are insufficient. A customer has a pain to get fast feedback of the quality of their products. The crises enable product marketing if alternative tests are passed and the product are sent to Q certification tests. The customer contacts were taken via RDP, but the further discussions and confirmations were sent via emails. Centexpel suggested to the customer to utilize distributed quality assurance concept where alternative tests can bring fast feedback and are gates to the official certification. Customer accepted the suggestion and sent samples to Centexpel, who sent a part of the samples to Mirtec and VTT. The tests were done distributed in 3 locations. Each test organization wrote test results into their own connectors. The process progression was written in the track sheet that is located in the common RDP connector. The certifier can read data from all connectors and finally write the certification when all tests were accepted. Then we go to the trusted data exchange services. We connect first to the RDP network connector. Connect then and press the catalog so we can see all the resources. The track sheet is seen as green, and it means that we can write into it. The track sheet controls and coordinate the whole process. Here all actions can be seen, and the resources of the other connectors are visible in blue. It indicates that they are read-only. Firstly, we can see the bacterial filtration test and its results, and then breathability test report, certificate. Okay, it was the particle filtration, that was the first one. And if we then go back, disconnect from that, and then we connect to the Sentexpel connector, connect into it, and catalog. Now all resources can be seen, and it is possible to write only to the bacterial filtration test report and the certificate resource. The other resources can be written when connected to related connectors. And some conclusions about RDP development and embedding in the Reservist-cells. The design, data forms, and the solutions worked quite well, according to the expectations. Also, the planned functions worked, even some tuning up would be preferred. However, it presumes that the fields of the forms and the guidance text are appropriate. The guidance texts have some development needs. They should be more tailored in each separate pages. This takes resources. The other development area is related to the email messages that are generated in customer contacts in the marketplace or when the coordinator sends a wake-up signal to the suppliers. It is preferred that the emails would be sent directly from the platform. Technically, there are several possibilities to arrange this function. It has connections to the user management, and it has also GDPR viewpoints. Some functions would have been easier to buy, for example, as Microsoft Azure services, but they would cause continuous costs. That would make it more difficult to keep the platform alive after the project. When the RDP development started, there was a lot of expectations and quite loose specifications. The operation protocols of Reservist-cells were developed simultaneously with the RDP development. For that reason, the development target was moving until the protocols became clearer. Also, expectations of new functions and features came up during the demonstrations. That's why the development continued during demonstrations and embedding phases. It was also a bit surprising how much the resources the test validation and finalizing of the functions needed. In addition, for testing separate functions, it is necessary to test and simulate whole process chains. Several small details related to data formats caused additional challenges in demonstrations. It became also evident that the platform needs to be consistent with the operation protocols and the business model. The final demonstration showed that when a crisis and a need occurs, everything must work directly and be clear. There is not time to fix functions, or the user is not willing to learn new systems. We summarized the experiences that we got from the IDS implementation and the demonstration. Availability of the IDS open source library components has developed slower than expected. The available user interfaces for connectors seems not to be applicable in the reservist type solutions. It means that they have to be developed case by case. The user interfaces also tend to become quite complicated. The implementation of connector in a company network face typically several challenges caused by company-specific cybersecurity requirements. This is not from this demonstration, but from the other projects that are ongoing at VTT. We can see potential in IDS technology, but the utilization of IDS can become a practical data transfer method when it is adopted widely in industry. And in the end, I would mention that this work was a part of Reservist project that was funded by European Union's Horizon 2020 Research and Innovation Programme. Here you can see contact information for Reservist project and Reservist Digital Platform. Thank you for listening.